on NPI.
Ion NPI brought to you by DigiKey. Congratulations, DigiKey. There's Ion NPI news about Ion NPI. I have this little thing that notifies me when there is a news article on DigiKey. Mm-hmm. Because they don't have an RSS feed, but you can sign up. But I actually know this is, I'm in the biz, so I want to, I have one for Mauser, one for Arrow, or DigiKey. So I got this right away. I'm like, oh, this is cool. And we have NPI coming up. So they added 100,000 NPI new product introductions and more than 100 new suppliers in the first quarter of 2025.
Including Cookie CAD.
Well, yeah, you know what I'm going to say. So first up, congrats, Mike Slater, Vice President of Global Business DigiKey, Big Inc. But what I wanted to say is I was reading this and then it said the most recent new supplier additions in the first quarter include companies like Cookie CAD. Cookie CAD, I was like, what's Cookie CAD?
Delicious.
Which produces 3D filament. And they do colors and different materials. So I'm like, hey, Noe and Pedro, have you ever heard of Cookie CAD? And they're like, no. And I'm like, okay. I went to Cookie CAD, and you know what they got? They have this really cool glitter filament and pastel filament. And they have this tool that you go and you upload your image and you make a cookie cutter, and then you can print it out and make a
Oh, fun. Perfect for the holidays. Cookie.
And of course, we walk our little kid around and we were singing, if it's good enough for Cookie, it's good enough for me. Yeah, C is for Cookie. So anyways, congrats.
Congrats, Cookie CAD and DigiKey.
All right. So anyways, this week's Ion NPI is Panasonic.
Okay, Panasonic. Yes, we've covered them a couple times for their sensors and stuff, but what they're really well known for is their batteries. And this week we're covering their ML and VL series of solderable, rechargeable lithium coin batteries. And these are kind of neat because they have the size benefits of a coin battery, but they're easy to solder, you don't need a holder, and they're rechargeable. So, of course, if you want coin batteries, there's tons of them available on DigiKey in various sizes. The most popular is like the 2032 or the 1220. We use them in a lot of products because if the energy density is quite good. At 2032, it's 3 volts at 250 milliamp hours, which is, enough to run, small electronics for a long time. So you'll see them used in remote controls and toys and, small portable gadgets where, you don't necessarily want a rechargeable battery or you're willing to go with a low cost coin battery. One thing that's a little annoying is you have to have holders for them. So we have a coin cell holder that people can use with their projects if they want to. Again, a small microcontroller, a couple of LEDs, maybe. Especially something that doesn't run all the time. It only runs when you press a button. That's why for remote controls, they're pretty common. Little RF beepers, tiles and air tags use a 2032. And they last about a year and then they're just user replaceable. You can get coin cells like in any grocery store. But for many products recently, if you needed something small and especially, if you didn't want to have customers have to open it and replace the coin batteries, a lot of companies have moved to using rechargeable lithium polymer cells, especially little packs like these. We have one that's 100 milliamp hour, but you can get them 20 milliamp hour, 10 milliamp hour. I mean, the batteries that are inside your little earpods, for example, those are rechargeable lithium polymer batteries. And they're tiny little tubes of 10, 20 milliamp hours a piece. You have to recharge them kind of often, but they will last a few hours. That said, there are some situations where you may not want a bulky lithium polymer battery, if size is important to you. Oh, that's different. Okay, sorry. So, what I thought was neat was, Panasonic, who is known for their rechargeable 18650 batteries, are used in EVs and in electric bicycles and almost every large pack rechargeable electronic device. If you open up most EV packs, they're actually 18650s, just tab soldered together. They also make this range of much smaller batteries that are lithium rechargeables, and they're about 3 volts, and the capacity is much smaller. So, you're seeing here, there's the 2020, which is kind of like a 2032 size, or there's a 2030 at the bottom. They're 45, 50 milliamp hours. 12 millimeter diameter is like 7 milliamp hours. But they are rechargeable. There's two variants. They're called the ML and VL series. Basically, if it's 20 millimeter diameter, it's going to be the ML, and if it's smaller, it's VL. I think it's just like the size affects the chemistry and how like you can craft the anode and cathode and fit it into the shape. Because again, most coin cells are lithium primary, not secondary rechargeables. And so they have to do a little bit extra work to get it to fit into this small size. They actually manufacture, the data sheets are going to have the coin cells themselves, like not with the tabs attached, and they'll tell you the nominal voltage and capacity. And they also have the discharge curve. So, like your lithium primary coin cells, they will discharge kind of quickly from 3 volts down a little bit. They'll stick around 2.5 nominal. And the discharge, if you look at the top right, it's expecting you to stay at like 120 microamperes. To get the expected capacity, you will want to use very low trickle charging. So this is not for like running something continuously. It is for something like, your tile or your remote or your, little beacon, something that is, or a real-time clock, something that's drawing a very small amount of current, and it'll last for a long time. And then you can see how long it'll last, based on the current consumption. You can get a couple days to like almost a year, depending on your current. They have very low self-discharge. I think it's about 2%. So it's not as good as a lithium primary, but it's better than like a nickel metal hydride. And then this is a 12 millimeter. There are actually a couple different sizes. They actually go even smaller. But this one has 17 milliamp hour capacity. So again, it's about, a fifth of a primary cell. Also, they're expecting you to draw more than, in this case, 25 microamperes. And then there's the tab option. So there's vertical and horizontal. I think obviously if you're buying a lot, they would customize it. There's one that's like super flat. But they're definitely hand solderable. Maybe even wave solderable if you have to. They're not reflowable. I wouldn't put this through the oven, but it's like a post processing state. But still, it's still much easier than soldering a holder and then like having to insert the battery. Where these really shine, I think, would be in real-time clocks. So, historically, this is like the first real-time clock that I ever worked with. It was, often soldered into PC motherboards or socketed into PC motherboards. And it's something that keeps time, right? So you have your main computer that has power, and it's like powered, 80, 90% of the time. But when you restart it, or if you have power loss, you still want it to know what time it is. And sometimes there's other settings, right, in the BIOS or something that are kept by the real-time clock. So for that, you would have a small battery inside that would last hopefully like a decade or two. Unfortunately, these are sealed. And so, when you eventually a couple decades later, your old retro computer real-time clock ran out of battery, you'd have to actually desolder or replace this to fix it. But a more common place you'll see this is, say, like a GPS unit or like a clock or a watch. Something where there's a primary battery for when it's functioning, when the display is on, when people are interacting with it. But then even if the battery dies, like you have a primary lithium polymer, lithium ion cell that's powering your phone, your laptop, your clock, your GPS, if that gets disconnected or like the power is lost, you might not even have enough power left over to trickle charge, keep the real-time clock going. And so having a secondary RTC battery like this one that you top up but will last you like a week or two could have like a much better customer experience. One thing to watch for though is, because this is a rechargeable battery, you do need to recharge it with a proper lithium polymer charger. The BQ25185 is a great one, which I like. But any battery where you can set the output voltage. This one, what's nice about it is you can set the output voltage, because remember, it's not a 4.2, 3.7 lithium polymer, it's a 3 volt. So you have to like look at the data sheet and pick the current to be, whatever, 10, 20 milliamps. You can't charge it too quickly. And also the floating voltage is not going to be 3.7 volts. So like this one, for example, you can adjust both the current and the voltage. Just make sure you do that. Don't just put a resistor and try to trickle charge it. Okay, don't do that. You're not supposed to do that with lithium batteries. And the data sheet says don't do it. Anyways, but if you do have a real-time clock, you don't want to deal with replaceable batteries. You want something that's easier to solder on, and you can recharge it with your built-in battery system because it's going to get power once in a while. You can get these in stock. Note they're lithium, so they will be ground shipped. I think they don't do air shipping for lithium. Lots in stock, lots of variations. I definitely think that if I'm going to do like a real-time, like an enclosed project or like a GPS, this would be a good option because I think people replacing the coin cell, especially if it's sealed in something, is a total pain in the ass.
Just like NPI?
Okay.
On NPI.